Welcome to submodule 2 of 3 on the Introduction to RSS. In this submodule, we will cover the different categories of rotary steerable systems and list some of the industry examples of rotary steerable systems. What we see here are the 4 types of rotary steerable systems as defined by the IADC, with diagrams shown in the lower half. Starting at the top, case 1 is the push-the-bit system. Here, pads extend from the tool body to push laterally against the borehole wall, forcing the bit to deflect. The diagram of case 1 shown at the top of the blue panel illustrates this lateral displacement. Examples include the SLB PowerDrive X6, Halliburton's iCruise, Baker Hughes AutoTrack, NOV's Vector Edge and Vector Zeal, and Weatherford's Magnus. Case 2 is the point-the-bit system shown in the second diagram. This design tilts the bit shaft relative to the tool axis to change direction. It provides smoother curves and is less dependent on borehole contact. Examples include Halliburton's GeoPilot, Weatherford's Revolution, Terravici, and Gyrodata's WellGuide. Case 3, illustrated third, is the permanently deflected bit design. The bit shaft is built at a fixed angle to the tool body, producing predictable curvature but less flexibility. The SLB PowerDrive Exceed and XL are examples. Case 4, at the bottom, is the hybrid system, combining push and point capabilities through articulation. The SLB Archer is the main example. Finally, a new category, at the bit steering, is shown separately, represented by SLB NeoSteer, which places actuation pads directly at the bit face for immediate directional response. The takeaway is that RSS is not a single technology, but a family of designs, each suited to different drilling challenges. Information was pulled from the Offshore Magazine 2015 Rotary Steerable Drilling Systems Directory. This table shows the competitive landscape. All major companies field RSS, but designs differ: push, point, hybrid, or at the bit. Claimed dogleg severities vary from 3 degrees to 18 degrees, and hole size ranges from 5.75 inches to 28 inches. The message is clear: RSS is a crowded market, and engineers must match tool choice to well objectives. What this does not show is that the more established service companies in this space have evolved through technological improvements and reliability, which the new entrants still need to build. The message is buyer beware. All these competing offerings will likely pass the technical requirements in a tender, but may be limited in terms of support and reliability. Examining the new technology offerings, which are based on the IADC Case 1 push-the-bit category. Top left, Halliburton's iCruise in the red housing displayed at a trade show. This is based on the SLB PowerDrive X6 push-the-bit technology. Top right, the SLB NeoSteer at-the-bit system. The bit has push-the-bit pads in the bit. Applying the push force at the bit significantly increased the doglegs that are possible. The initial focus was on the shale plays in the US land. Bottom left, Weatherford's Magnus. This again is based on the SLB PowerDrive X6 push-the-bit technology. Looking at Baker Hughes offerings. At the top is AutoTrack G3. This is a standard push-the-bit RSS. The bias unit has a variable force pad to vary the dogleg. Below this is the AutoTrack Express, a smaller assembly designed for rapid deployment. It is a streamlined modular variant of the G3. The key strengths are faster BHA assembly and deployment, resulting in less rig time, simpler maintenance, and turnaround time between runs. The tool has a long flex sub above the control unit to increase the dogleg capability. Third is the AutoTrack Extreme. This is a push-the-bit technology that has been combined with an integrated mud motor, delivering over 400 RPM at bit for higher ROP. At the bottom of the slide, the ATK Express BHA schematic is shown with Navitrack MWD, flex sub, and a modified ATK steering unit. To the right is a cross-section diagram of pad actuation inside the borehole. The bias unit is non-rotating, which can pose a risk for differential sticking. In the next slide, a video will explain the operation of the auto track. On this slide, we see Halliburton's GeoPilot 9600 series systems displayed vertically from top to bottom, each tool with a short description. At the top, the GeoPilot XL 9600 is shown. This is a point-the-bit rotary steerable tool offering high reliability and speed. Its design tilts the bit shaft to change trajectory, giving smooth curves and accurate control. The second tool is the Solar GeoPilot XL 9600. It looks similar, but it is rated for extreme HPHT conditions, up to 175 degrees Celsius and 30,000 pounds per square inch. This makes it suitable for the most hostile environments where standard tools cannot operate. Next is the GeoPilot XL with stabilized lower housing, shown with a red stabilizer section. This modification provides better control in soft formations with low to moderate build rate requirements, preventing tool instability. Below that is the GeoPilot Dirigo, formerly EDL. This version is designed for enhanced dogleg capability, allowing aggressive build rates. It is ideal for challenging curves or sidetracks. Finally, at the bottom, the GeoPilot GXT9600 is presented. This combines the GeoPilot with a GeoForce uniform wall motor, delivering higher torque and improved ROP, making it suitable for long laterals and hard formations. Overall, this demonstrates Halliburton's comprehensive RSS portfolio, from robust standard tools to HPHT-rated high build and high torque systems, encompassing nearly every drilling environment. Looking at the detailed schematic on the right of Halliburton's GeoPilot rotary steerable system, the central image shows a cutaway view of the tool body, with labelled internal components extending approximately 18 feet. Starting from the left, you can see the rotary seal, anti-rotation device, and bearings. Moving along, there is the pressure compensator, control electronics, and sensors. Toward the bit end, the eccentric cam unit and near bit stabilizer are highlighted, showing how steering forces are applied. The system measures at-bit inclination with azimuthal gamma ray located just 3 feet behind the bit, giving precise well placement data. The outer housing rotates slowly or remains stationary, while the internal drive shaft continues to spin, delivering torque to the bit. Anti-rotation wheels help lock the housing against the borehole wall, limiting unwanted rotation. Finally, the note mentions that the maximum dogleg severity was reduced in the redesign, balancing durability with steering capability. The GeoPilot works as a point-the-bit system. By tilting the shaft using the eccentric cam unit, it changes the bit's orientation relative to the borehole axis. This delivers smooth, continuous steering while maintaining full rotation. The schematic shows how mechanical design and sensor placement combine to produce precise controlled directional drilling. Some of the issues encountered with technology relate to the anti-rotation wheels, which can struggle to maintain integrity with the borehole, particularly in high stick and slip conditions, as well as in soft formation or enlarged holes. This is also a non-rotating element that has the potential to get stuck. The next slide is a video showing the operation of the tool.
GeoPilot Rotary Steerable System. As part of the pilot fleet of automated drilling systems, the GeoPilot is the industry's most proven point-to-the-bit rotary steerable system. Azimuthal gamma and inclination sensors just 1 metre from the bit provide tight control on wellbore placement and geosteering. The bit is pointed by flexing the internal drive shaft. The advanced geospan downlinking system provides total control while on-bottom drilling without interrupting the drilling process. The shaft is flexed using a pair of eccentric rings controlled by a gear and clutch system. This design is capable of over 12,000 possible settings, generating up to 6 degrees per 30 metre doglegs, and makes the GeoPilot virtually immune to formation tendencies. The system is designed to exploit the proven benefits of extended gauge bits: low wellbore friction, improved hole cleaning, low vibration, and longer bit life. This makes the GeoPilot ideal for drilling extended reach wells and ultra-long horizontal sections through the reservoir for maximising production. The GeoPilot is also excellent for open hole sidetracks from existing wells. It is well suited to drilling everything from simple wells to the most complex 3D well designs, such as connecting multiple marginal targets for higher recovery.
Weatherford's RSS Revolution appears top, which show a photo of the full-length revolution tool, labelled with its non-rotating section. At the bottom right, a cutaway schematic illustrates its internal tilt mechanism. The revolution is a point-the-bit RSS, which means the bit shaft itself tilts to steer the wellbore rather than relying on pads pressing against the wall. The top image emphasizes the long body with stabilizers, while the lower schematic highlights how the mandrel tilt system works inside the tool. Weatherford is positioning revolution as a smoother, more precise alternative to push-the-bit systems. The non-rotating sleeve reduces spiraling, which improves hole quality and makes casing runs easier. Revolution is particularly effective in complex well paths requiring smooth curves and accurate directional control. The non-rotating sleeve design is a compromise that limits operating parameters and increases the risk of getting stuck. The next slide shows a video on its operation.
It hole diameters from 5 7/8 to 22 inches. The RSS assembly consists of an integral stabilizer fitted on the Hell MWD collar, a short non-rotating bias unit, and a lower pivot stabilizer. The upper collar of the RSS bias unit houses control electronics, the brains of the tool, and the lithium battery power pack. The control electronics insert contains navigational sensors, including the accelerometer and magnetometer package, a CPU, memory boards, and the world's first high-temperature angular rate gyro to detect and mitigate damaging shock and vibration when drilling in extreme environments. The non-rotating unit mounted on the main rotating shaft enables the shaft to be deflected in any required direction to accurately control the well path. Anti-rotating levers, or ARLs, mounted radially on the sleeve stabilizer blades hold the bias unit non-rotating sleeve steady. The lower pivot stabilizer acts as a fulcrum point, transferring shaft deflection and pointing the bit face in the required direction. The RSS bias unit drive shaft runs through the center of the non-rotating sleeve, delivering torque to the bit. The shaft can be deflected in any direction at the appropriate angle to build the desired dogleg. The drive shaft deflection is transferred through the pivot stabilizer and therefore points the drill bit face in the required direction with the correct amount of tilt to achieve the planned well path. The drive shaft is deflected off-center by the piston manifold housed inside the non-rotating sleeve. Deflection is parallel to and along the length of the sleeve piston manifold housing. Therefore, no point load is transferred to the shaft. The Revolution system piston manifold consists of 12 banks of pistons mounted 30 degrees apart. As the center shaft rotates, it operates an internal hydraulic pump. A commutating valve is located on the rotating shaft. As the shaft rotates, the valve passes each bank of pistons once per revolution. The position of the commutating valve is referenced to the navigational sensors mounted in the control electronics. Therefore, the position of the valve with respect to high side tool face or magnetic azimuth is known at any given time. A solenoid valve is operated when the commutating valve is adjacent to the bank of pistons that are to be energized. When the solenoid valve operates, the high-pressure hydraulic fluid is directed to the bank of pistons, pushing them outward and deflecting the piston manifold and rotating shaft in the opposite direction. The Revolution suite includes 4 versatile systems to meet a range of drilling challenges. With a point-the-bit design, real-time measurement of key parameters, and advanced communication, the Revolution RSS helps you drill wells precisely, efficiently, and smoothly.
This slide shows the SLB rotary steerable family. All the tools are fully rotating. Starting top right and working clockwise, Power Drive X6, Power Drive Orbit, Power Drive Ice, Power Drive Exceed, Power Drive Archer, Power Drive Vortex, and Power V. At the top left corner, NeoSteer, the at-the-bit system, is highlighted separately. This shows the SLB broad portfolio covering every RSS category: push the bit, point the bit, permanently deflected, and at the bit. Each system is tailored for a specific operating envelope. Ice for HPHT, Archer for high doglegs, Exceed for harsh environments, Vortex for torque and reaming, and NeoSteer for rapid, precise steering. SLB has positioned itself as the only provider covering the full range of RSS technologies, enabling operators to choose the best fit tool for any environment. To recap, in this submodule, we reviewed the different categories of rotary steerable systems from Case 1 to 4 and the additional at-bit steering system from SLB. We then looked at the industry examples available in the market today, including Baker Hughes AutoTrack, Halliburton's GeoPilot, Weatherford's Revolution, and the full suite of offerings from SLB. This ends submodule 2 of 3 on the introduction to RSS. Thank you, and please proceed to the quiz.